Hello everyone and welcome to Grade Up. My name is Ashish Sir and today we will be starting with surveying engineering. Okay, so in surveying, the first topic which we will discuss is linear measurement. As you can see on the screens, I have written the heading. Okay, so this is the first among the chapters which is very important from objective point of view. Okay, so in linear measurements, we'll talk about the scales, the corrections, and some basics, well-conditioned triangle, and some basic definitions. Okay, which often appear in objective type questions. Okay, so we'll start with the session now. Now, first of all, let's see some basic definitions. Okay, so I will be taking some important ones. Okay. Which are important from the examination point of view. So, the first among this is baseline. So, if suppose there is some surveying area, okay, if suppose this area is to be surveyed, this is some property, okay, which you want to survey for any work, it can be any work for construction, okay, or for that matter for any social work, okay. So, the baseline is the, from definition you can see, longest survey line which divides the survey area into two equal halves. Okay, so baseline will be the area which approximately divides the survey area into two halves. Okay, so from here, if we want to draw the survey line, it will be something like this. Okay, so this we can say as baseline. It will approximately divide the area into two equal halves. Okay, so that is the definition. In this definition, two approximate equal halves, this word is important. Okay, now the second one is check line. Okay, so the second definition is check line. Now check lines are, as you can know from the name itself, it's getting clear that it is used to check the survey. Okay, and what you check? You check the accuracy of the survey. So the line used to check accuracy of the survey work. Okay, so this checks the accuracy. Okay, so how it will be done? If suppose there is some object here, okay, and you are drawing the check line. So if from here, if I measure this distance and this distance, okay, so since the object is fixed, that distance will be from the other lines will be fixed. Okay, so those are known as the check lines. Okay, so in order to check the accuracy of your survey, they should not differ much. Okay, there is certain error which is permissible, but beyond that value it is not permissible, because then the accuracy gets affected and it will not be very correct for the future works. Okay, now the third thing is main station. Okay, so what are main stations? Stations that command boundary of the survey. Okay, stations that command boundary of the survey. So roughly around these proximities we will take main stations. Okay, so these will the stations which will be on the periphery, mostly on the periphery. This may be inside, but mostly these stations will be on the periphery. So they command the boundary of the survey. Okay, so boundary of the survey, this word is important here. Now the another thing is tie station. Okay, so tie stations are stations on survey line joining two main stations. Okay. So tie stations will be something like this. If suppose this station and this station is joined, okay, so somewhere in this survey line there will be a tie station. Okay, this will be a main station, this will be a tie station. Okay, so this will be a main station, this will be a tie station. Okay, now there is one more thing, that is offset. What is an offset? Okay, so offsets are distance of objects, distance of object from the survey line. Okay, so distance of object from the survey line. If suppose there is one tree here, okay, so from this baseline or this survey line, whatever is the distance, okay, so this distance can be perpendicular or this distance oblique distance, okay, it can be any one. Okay, so here this is perpendicular offset, this distance, and this is oblique offset. Okay, so offsets can be either perpendicular, that is at 90 degree, or they can also be oblique angle other than the 90 degree. Generally perpendicular offsets are taken, but at times if not possible then oblique offsets are taken. Okay, so these are some of the main definitions which are important from the first chapter. Okay, now I hope you get all these correctly. Okay, the words I have highlighted, please note them down, because particularly highlight them in your memory as well. Remember those, because in objective questions these words you have to find, and then only you will be able to mark the correct answer. Okay, now the second thing is, what is a well conditioned triangle? Okay, now you might have heard this word particularly in competitive examinations as well as in the surveying subject. Okay, so what happens is, in chain survey, okay, so in chain survey we do triangulation. Okay, we are measuring the distance with chains, okay, and forming the triangular these entities. Okay, so the main station to be selected in chain survey, main stations are selected such that they satisfy the condition of well conditioned triangles. Okay, so in chain survey we have to select main stations such that they satisfy well conditioned triangle condition. Okay, now what are the conditions? So a triangle is said to be well conditioned if all intersections are clear. Okay, so clear for plotting position, Okay, so what this means is, if suppose I am constructing a triangle, okay, if suppose this is the triangle I have constructed, So these intersections, okay, the stations at these stations, the stations at these intersections are clear for plotting. If suppose I construct a triangle like this, okay, so this intersection is not very clear, okay, so at this intersection it will be difficult to plot the station, okay. So for this condition, you might have heard the angles must be greater than 30 degree and less than 120 degree. This is the condition for well conditioned triangle, okay, because if the angle becomes very less, okay, so it will not be beneficial, it will not be clear for plotting the position, while in this triangle it is clear, okay, you can plot it here, 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 it's quite clear, but at this station it will be very difficult to plot these positions at this particularly this area, okay, so it will be very difficult, okay. So this is the condition for well conditioned triangle. Also, as you all know, equilateral triangle is the most appropriate well conditioned triangle, okay. So equilateral triangle is the most appropriate this well conditioned triangle, okay. Please take a screenshot and we'll move to the next topic now. Now we are done with the basic definitions and well conditioned triangle, okay. All right. Now after this, we'll move to the equipments which are used in the linear measurement. Equipments for linear measurement. Okay. So now first thing is chains, okay. Now in chains, generally three types of chains are there. The first one is engineer's chain, then there is Gunter's chain, that is also known as surveyor's chain, okay, and the third one is revenue chain. Now from objective point of view, you have to remember this, the length and number of links. So engineer's chain is 100 feet 100 links, okay. So as we all know, engineers are the best among the people, so they have not left any ambiguity here, just a simple 100 feet 100 link, okay. The simplest, in the simplest possible way, okay. So Gunter's chain is 66 feet and 100 links, okay. So Gunter's chain is 66 feet 100 links, okay, and revenue chain is 33 feet and only 6 links, okay. So these three things are important from objective point of view, okay. Engineer's chain 100 feet 100 link, Gunter's chain is 66 feet 100 link, revenue chain is 33 feet 16 link, okay. Please remember them, they often appear in examinations, okay. So tape, from tape only one point is to be mentioned, the inward tape is the best, okay. In terms of accuracy, inward tape is the best. Also, it has nickel about 34%, okay, sorry 36%, and steel 64%, okay. So from tape only this point is enough from objective point of view, okay. Other than there also equipments are pegs, arrows, okay, ranging rods, but these the questions do not appear from them, so I am skipping those, okay. Now there is cross staff. Now cross staff is used in surveying, okay, for setting offsets, okay. So it is used for setting offsets and setting right angles, okay. So there are various types of cross staffs. there is French cross staff. Okay. Also there is open cross staff. Okay. So French cross staff and this open cross staff. Now French cross staff is less accurate. Okay. It is less accurate than open cross staff. But with what is the advantage? You can plot 45 degree and 135 degree. Okay. Plot 45 degree and 35 degree with French cross staff, but with open cross staff you cannot plot these angles. You can only plot 90 degrees, 180 degrees. Okay. So French cross staff is less accurate, but the advantage is it can plot 45 degree and 135 degrees. Okay. So this is about the cross staff. Then there is optical square. Okay. So optical square is the upgraded version of cross staff. Okay. So it is used for setting right angles. Okay. So it is used for setting right angles. Okay. Also it is accurate. I have to already told it is upgraded version of cross staff, so it is more accurate than cross staff. Also angle between mirrors is 45 degree. Okay. So angle between mirrors is 45 degree. Okay. Also one more equipment is there, that is clinometer. Often in objective questions you will get this word, clinometer. Now what it is used for? It is used to measure angle of slope of ground. Okay. It measures slope angle of the ground. Okay. So from equipments for linear measurements, these are the ones from which in objective you may get question. Okay. So chains are type of chains 3. Then tape is inward tape, cross staff French and open, which is accurate, and what is the advantage of French cross staff. Then there is optical square, it is accurate than cross staff, angle is 45 degree, and clinometer is used to plot the slope angle. Okay. So this is about the equipments. Now let's come to the next topic, that is scales. Okay. So what are scales? Scales, see, the actual distance on ground cannot be you cannot plot a map of such a large dimension. Okay. So use scales. Okay. So it reduces the distance, but you also use a scale, so you may be able to estimate from the map distance, you can estimate actual ground distance. So for that scales are used. Okay. So there are various ways of giving the scales. Okay. Representing the scales. Representative fraction factor or fraction, whatever you know, RF. Okay. In short, it is known as RF. Now what is RF? RF is nothing but map distance by ground distance. Okay. So it is map distance by ground distance. Now there is also plane scale. Okay. Plane scale. Now plane scale is used to measure two dimensions. Okay. Like the scale which you use generally, those are plane scales. You measure centimeter and mm mostly. Okay. So they measure two dimensions. Now then there is diagonal scale. Now in engineering drawing you construct this one, diagonal scale, and the advantage is it measures 3 dimensions. So if you are measuring say decimeter, meter, and you are measuring centimeter, mm, and 1/10 of mm. Okay. So like this it measures 3 dimensions. Okay. Then you know about the vernier. Okay. This is the most prominent one. Now by vernier you have least count of vernier. Okay. Then it is about this vernier's distance upon number of main scale by number of divisions. Okay, so this is vernier. Then there is, okay, so important one is from examination point of view is shrunk scale. Okay, so the maps constructed around 20 to 30 years ago, they tend to sink. Okay, as the paper gets old, it shrinks. Okay, so you have to construct a shrunk scale because then accuracy will be affected. Okay, so you have to use, you have to get the shrinkage factor. So shrinkage factor is shrunk length upon actual length. Okay, so shrinkage factor is equals to shrunk length upon actual length. Okay, now with this you have to estimate the shrunk scale. So shrunk scale is original scale into shrinkage factor. Okay, so this is now the correct scale. So if after 20 to 30 years you are estimating the ground distance from the map distance, okay, so for that map this original scale which was there, it has become inaccurate. So now this shrunk scale will be used. This is the more accurate version. Okay, so this is the this is about the shrunk scale. Please highlight this one because this is important from this question point of view. Okay, this is about the scales. Now there are 2 points, error and correction. A lot of confusion is with regard to this. So what is error? Error is what you measured minus what is true. Okay, so error is measured minus true. Correction is the negative of error. Okay, so in order to remove the error you have to apply correction. Okay, so it will be negative of error. Okay, so minus of error will be true minus measured. Okay, so please remember these two things. You can remember one and you will invariably remember the second one. Okay, so if error is equals to measured minus true, correction will be opposite of that, that is true minus measured. Please take a screenshot of this and we'll move to the most important part of this chapter, that is tape corrections. From this chapter in objective, most number of questions will be from these tape corrections. Okay, tape correction and shrunk scale. Okay, so you should have a good and accurate idea of all the types of corrections. Tape corrections. Okay. So now the first correction is correction for standardization. Okay, so if the tape due to if the length of the tape changes, okay, if you stretch it a bit more, okay, so applied when actual length is different from standard length. It is applied when the actual length of tape is different from the standard length. In that case the correction CA is C upon L into capital L. Okay, so the terms are important here. Okay, where CA is correction for length, okay, L is designated length of tape. Okay, capital L is measured length. Okay, it is the length which you have measured length of line. Okay, and C is the correction per unit length. Okay, per unit tape length. Okay, so this is the first correction. Okay, if the actual length of tape is different from the designated length. Okay. Now the second is correction for temperature. Okay. So in case of temperature, the corrections Ct is L alpha T minus T naught. Okay. L alpha T minus T naught. Now where L is, Ct is correction for temperature, L is measured length. Okay. So L is measured length, alpha is thermal coefficient. Okay. Thermal coefficient of expansion. Okay. T is the temperature at the time of measurement. Time of measurement, and T naught is standard temperature. Okay. So T naught is the standard temperature. So the correction for temperature, these are the two correction for temperature is Ct is L alpha T minus T naught. Okay. So here, if suppose if Tm is this T is greater than T naught, okay, so length of tape will increase. Okay. So error will be negative and correction will be positive, and vice versa. If T is less than this, then the correction will be negative. Okay. So third one, correction for pull. So correction for pull, no, correction for pull Cp is P minus P naught into L upon Ae. Okay. So where Cp is correction, okay, P is the pull applied, P naught is standard pull, L is measured length, A is cross section area, and E is modulus of elasticity. Okay. So this is correction for pull. Okay. Now this fourth correction, that is correction for sag. Okay. So correction for sag Cs is WL square upon 24 P square, okay, PM square, and this is, please note, this is subtractive always. This the plus the positive and negative nature depends on this temperature T. Here it depends on P applied pull, but here it is always subtractive. Okay. So this is one property which you should remember. Okay. Now there is one note here about the normal tension. So what is normal tension? In normal tension is pull at which the correction for pull and correction for sag compensate each other. Okay. So this is the nature of this depends on P, while this is always subtractive. So if we adjust the pull P such that these two cancel each other, okay, the amount of by which this correction due to pull is positive is equal to the amount by which this correction due to sag is negative. In that case, these two will cancel each other, and that pull is known as normal tension. Okay. So to get that, you have to equate Pm minus P naught into L upon AE should be equal to W square L upon 24 PM square. So, with this equation you can easily get the normal tension. Okay. Please take a screenshot and we will see more corrections. Now, fifth correction is correction for slope. Okay. So, correction for slope is CS is h square by 2L. This is also subtractive in nature. Okay. Now, where h is difference in elevation between ends. Okay. Is known as difference in elevation between ends. Okay. And L is inclined length measured. Okay. So, this is correction for slope. See, I am not going into the theory of that because from objective point of view it is not important. So, you should remember these formulas. There is not much theory inside these topics. So, you should not waste your time because there is very less time left for the actual examination. So, you should be able to solve the questions and come out of that problem as soon as possible. You will not get much time to study these. Okay. Now, there is correction for misalignment. Now, the formula is similar to this one, that is Cm is equals to h square by 2L. The last correction is correction for mean sea level, yes, for MSL. Okay. So, for MSL the correction is CH is equals to LH upon R. Okay. Where L is measured length, H is difference in height and R is radius of curvature of earth. Okay. It is about 6370 kilometer. Okay. 638 kilometer. Okay. And this is also subtractive. Okay. So, these are all the corrections which you should remember. Please take a screenshot. This one. Now, there is one small thing left, that is limiting length of offset. Offset, I have told you what are offsets. Okay. So, the distance, the maximum length of offset is not unlimited. Okay. You cannot measure infinite distance of offset. Okay. So, there is a certain length which is to be restricted in order to ensure the accuracy. The more the length you measure, the greater will be the error. Okay. So, in order to limit the error, there is a value of limiting length of offset. Offset is limited to a particular length. Okay. So, it is defined as maximum length of offset to be measured, offset, okay, such that the error in measuring this distance, such that the error produced is limited to a certain value, and generally this value is 0.025 centimeter. Okay. So, this is the definition for limiting length of offset. It is the maximum length of offset such that the error produced is limited to a certain value, and that value is 0.025 centimeter or 0.25 mm, whatever in units you can definitely play. Okay. So, there are two cases arise: effect of error in laying direction only. Effect of error in laying direction only. So, in that case the limiting length of offset is S upon 40 into sine theta. Now where L is the limiting length of offset, okay. S is the scale, okay, scale, and there is a particular representation for this. 1 centimeter is equals to S meter, okay. So if the scale is given to you in any other units, you have to convert it in this format. 1 centimeter is equal to S meter. Then only you will get the value of S. Okay. And theta is angle of offset. Angle of offset with respect to vertical. Okay. So if suppose this is the line, this is the offset, okay. So this is the vertical line, so this will be the value of theta, okay. So this is when effect of error in laying direction only. Now if there is error with respect to effect of error in laying direction and length as well, okay. So in that case, the limiting length of offset is L is equals to 1 upon sin theta under root S upon 40 whole square minus x square, okay, where x is error in linear measurement, okay. Rest all are same. S is the scale, theta is the angle with respect to this vertical direction, okay. So I hope this is clear to you. Please take a screenshot. Now we'll move to the questions. So first question, okay. So the questions from these will be very easy, okay. From RRB JE and SSC JE point of view, the questions are asked are generally easy, but you have to take care of units, okay. Please take care of units very well. So the first question says the representative fraction 1 upon 1800 measures means that the scale is. So 4 options are given to you, okay. You can easily solve this, okay. Quickly provide me with the answers. So RF says 1 upon 1800. It means 1 centimeter is equals to 1800 centimeter, and you know there are 100 centimeters in 1 meter. So 1 centimeter will be equals to 18 meter, okay. So the correct option to this answer will be yes, C, correct, okay. So C is the correct answer to this question, okay. See, it seems very easy, but in examination pressure, okay, exam pressure, you may be able to do it incorrectly. So you have to take, as I have already told you, you have to take care of the units, okay. Right. So this is the first question, okay. Second question. Now a surveyor measured the distance between 2 points on the plan drawn to a scale of 1 centimeter is equals to 40 meter, okay. The result was 468 meter. Later, however, he discovered that he used a scale of 1 centimeter to 20 meter. So true distance between the points will be, okay. So we will extract the data. See, measured length here is 468 meters, okay. Now if I want to get the RF of correct scale, so RF of correct scale is 1 centimeter is equals to 20 meter, okay. Later he has found that 1 centimeter is equal to 20 meter is the scale which he actually used. So RF will be 20 meters into 100 centimeters. So 1 upon 2000 is the RF of correct scale, okay. Now RF of wrong scale which he used is 1 by 40 into 100, that is 1 upon 4000, okay. So this is the data which is given to you to find you have to find the correct length. Okay, so the formula is, you all know, measured length, wrong is equals to true. Okay, so measured length into RF of wrong scale, that is equals to true length into RF of true scale. Okay, so measured length into RF of wrong scale is equals to true length into RF of true scale. So measured length is 468 meter. Okay, wrong scale is 1 upon 4000 is equals to true length. You have to calculate this one, and RF of true scale is 1 upon 2000. Okay, so true length is equals to 234 meters. Okay, so 234 meters is option A. Okay, so option A is the correct answer to this question. I hope you have got this point. Please take a note of this one. Okay, it will be very helpful in questions. Measured, this is measured length, that is the wrong length into RF of wrong scale is equals to true length into RF of true scale. You need to extract this data from these the text. Okay, you have to identify it correctly. Okay, we'll see the next question now. Now this question is also of units. I have included this question particularly because students often tend to, since we are well versed with centimeters, meters, kilometers, okay, but not with inches and feet, okay, which is quite prominent in foreign countries, but we are not quite familiar with this, so I have included this one. Okay, so the scale is reading 1 inch is equals to how much? 50 feet. So this is the scale which is provided to you, and you have to find the equivalent scale. So 1 feet has 12 inches. Okay, also I would like to add additional information here. 1 feet is equals to 0.3048 meters and 1 inch is equals to 2.54 centimeter. Okay, this is some additional information you can note down. Okay, so now coming back to the question. So 1 inch is equals to 50 into 12 inches. So 1 inch, so the scale becomes 1 is equals to 600. So 1 unit is equals to 600 units on the ground. Okay, so if I talk about centimeter and meter, so 1 centimeter will be equal to 600 centimeters. So 1 centimeter will be equal to 6 meters. Okay, so the correct option is B. Okay, so B is the correct answer to this question. Okay, B option. Okay, please note this extra information. Okay. Now next question. The side of a square area were measured by a chain of length 20 meter and the area was found to be 3200 meters square. But it was found that the original length of the chain was 19.8. Find the correct area. Okay, so here now area is provided to you, that is 3200 meters square. So if I calculate the side, it says under root of area, that is under root of 3200, that is 56.56 meters. Okay, so from the given information I have calculated the side, but this is incorrect. Okay, so you have to calculate the actual side length. Okay, so actual side length will be 56.56 into what was the original length was 19.8 and 20, the incorrect length is 20. Okay, so the length of the side will be 56 meter, which you will get. So the correct area will be side square, okay, side whole square, that is 56 whole square, and if you do that, it is 3136 meter square. So 3136 is option C. Okay. See, this I have calculated using that formula only. Okay. Wrong into wrong is equals to true into true. Okay. So the true length of the side will be wrong into whatever was the wrong divided by the true 20 meters. Okay. Okay. Now we will move to the next question. Now this question is from corrections. Okay. I have tried to include the corrections which are important from examination point of view. Okay. So steel tape is 30 meter long, okay, at a temperature of 65 degrees Celsius when lying horizontally on the ground. Its sectional area is 0.082 square meters. Its weight is 2 kg and the coefficient of expansion is this much degree per Fahrenheit. The tape is stretched over 3 equal spans, and calculate the actual length between the end graduations using the following condition. Now pull is 18 kg, temperature 85 degree Fahrenheit, and E is given to you 2.109 into 10 raised to power 6 kg per centimeter square. So a lot of data is provided to you. Okay. So if I want to write the given information, okay. Given information, if I want to write, there is length L 30 meters, okay, at a temperature of 65 degree Fahrenheit. So this is T naught, that is 65 degree Fahrenheit. There is cross sectional area is 0.082 square centimeter square. Okay. What more? Your weight is 2 kgs. Okay. Then there is coefficient of expansion 65 into 10 is power minus 7. Power minus 7 per degree Fahrenheit. Alpha is given to you. Then there is temperature T, 65 degree Fahrenheit. Also pull is given to you. Okay. So P minus P naught is 18 kgs. Okay. Here standard pull and all the standard pull and the pull applied is not given. So this directly we can take P minus P naught is 18 kg. Also E is given to you. E is 2.109 into 10 raised to the power 6 kg per centimeter square. Okay. So this is the information which we have extracted. Also there are 3 number of spans. Okay, n is equals to 3. It will be used in the sag case. Okay. Now the first correction is for temperature Ct. So it is L alpha T minus T naught. L is 30 meters, alpha is 65 into 10 raised to power minus 7 into T is 85 and T naught is 65. Okay. So if I write this one, this is positive plus, if you simplify this much. Okay. So plus 0.0039 meters. This is the correction due to temperature. Okay. Now the second is correction for pull, Cp. It is P minus P naught into L upon AE. Okay. So it is 18 kgs, length is 30 meters, divided by area is 0.02 square centimeter, and E is in 2.109 into 10 raised to the power 6 kg per centimeter square. So you don't need to convert this into meter square. This answer will directly come in kg, because kg here cancel, centimeter square divided by centimeter square it will cancel, and this is in meters. So directly this correction due to pull will come in meters. Okay. So if you solve this, it is equal to plus 3.123 into 10 raised to power minus 3 meters. Okay. Now third correction is correction for the sag. Okay. Now correction for sag is, the formula is as 24 n square pm square p square. So this was 18 kgs. Let us assume p is 0. Assume. Okay. So here this p. So W square n is the formula which I earlier gave, that was for only one span. So here 3 spans are there. So 3 values of the sag. So n divided by n square will also be here. Okay. So the if you put the values, W square is 2 square into L is 30 divided by 24 into n square is 3 square and p is 18 whole square, and this will be negative. Okay. So minus of 1.714 into 10 raised to power minus 3 meters. Okay. So only 3 corrections will be there. There won't be any correction for elevation. Okay. For the slopes, there won't be any correction, and any other corrections there are, it is not mentioned. Okay. So we'll only do these 3 corrections. So the true length will be 30 meters plus 0.0039 meters, which is temperature correction minus plus 3.123 into 10 raised to power minus 3 meters plus minus 1.714 into 10 raised to power minus 3 meters. So the true length will be 30.005 meters. Okay. So this is the correct answer to this question, that is option number B. Okay. Only these 3 corrections will be there. There is no correction for slope or misalignment or elevation. Okay. So I hope you have got this one correctly. Okay. Moving on. Now this is, since there was in this question there was no slope correction, so we have included the question for slope, so that you get a practice of slope correction as well. Okay. The slope correction for a length of 30 meter along a gradient 1 in 20. Okay. So the length is given to you 30 meters. Okay. And the gradient is 1 in 20. Okay. So for 20 meter length, h is 1 meters as per the gradient it is mentioned. So for 30 meter, h will be 1 upon 20 into 30, that is 1.5 meter. So slope correction CS is minus of h square by 2L. So h for our length 30 meter, h is 1.5 meter and not 1 meter. Okay. So please take care. That's why this question has been included. You have to take care of this one. Okay. So h is 1.5 square into 2 into 30. Okay. And that is equals to 3.75 centimeter in negative. Okay. So there is, the sign is a material here, because it is not mentioned in anyone. So the option which matches is A, that is. Now here it is coming in meters, so you have to multiply it by 100 to convert it into centimeters. Okay, so answer will be 3.75 centimeters. So A is the correct option. Moving on to the next question. Now this is of shrunk scale. Okay. Now the plan of an area has shrunk such that line 100 centimeter now measures 98.5 centimeters. If the original scale is this much, the value of shrinkage factor is. Okay. So it is only asking shrinkage factor, not the shrinkage scale. First of all, take care of that. Okay. So shrinkage factor is, okay, the shrunk length, that is 98.5 centimeters divided by the original length, that is 100 centimeter, that is 0.985. Okay, so simple, this is the simplest of the questions, so it will be option A. However, if here it would have asked shrunk scale, so shrunk scale would have been, the original scale is 10 centimeter by 10 meters, so 10 into 100, this is the original scale, and into shrinkage factor 0.985. Okay, so 10 cancel, so 0.985 divided by 100. Okay, so this would have been the shrinkage shrunk scale. So with this is the more accurate scale now, and if today we are measuring a distance from the map, then we will use shrunk scale and not the original scale. Okay, moving on to the next question. Now correction per chain length of 100 links along a slope has a rise of 1 unit in n horizontal units. Now here we are talking not in meters or everything, we are talking in links. Okay, so n horizontal is equals to 1 vertical, okay, as you have been provided. Okay, so 100 horizontal is equals to 1 upon n into 100 verticals. Okay, so that is 100 by n vertical. So this becomes the value of h, okay, for this much length, 100 links. Okay, so h is 100 by n and L is 100 links. So slope correction is h square by 2L 100 upon n whole square divided by 2 into 100. Okay, so it will be 50 by n square. So 50 by n square is A, which is the correct answer. So we have solved 2 questions with respect to this. This is not only valid for any units, it can also be valid for links. Okay, that's why this question has been included. So the basic algorithm remains the same of solving the question, only you have to take care of calculating the value of h here. Okay, so do not get worried that it is asked in links and per link length is not given to you. It doesn't matter, it is chain length, so you can apply for this condition as well. Okay, so with this we have come to the end of this session. I hope this was helpful to you. In the coming session we will be seeing compass survey and other topics of the surveying. Okay, so prepare very well for all these subjects which we have already studied. Building material, revise, keep revising them, keep practicing, and prepare yourself for the forthcoming exam. Okay, thank you and have a very good day.